You know what are parallel lines? The two lines which cannot intersect, however far they are extended to both directions, are called parallel lines. Parallel lines never meet. And what's a transversal? A transversal is a line which intersects the two lines. Those two lines are either parallel or non-parallel. So here we are going to learn about parallel lines and its transversal. Suppose let these two lines be parallel. M, N, small letter M, small letter N. M and N be two lines which are parallel to each other, and let this line T is a transversal intersecting the two lines at two different points. These are the two different points. It will be P and Q. Okay. Now, when two lines are intersected by a transversal, 8 angles are formed. These are the 8 angles. 1, 2, 3, 4, 5, 6, 7, and 8. Now, 8 angles are formed. We know that yesterday we studied when two lines are intersected, 4 angles are formed, and these 4 angles are categorized into two different types pairs, linear pair and vertically opposite angles. A linear pair forms supplementary whose sum is 180 degree, and vertically opposite angles are equal. When two parallel lines are intersected by a transversal, 8 angles are formed. Now, taking one from each group, there are 3 different pairs of angles formed. How many pairs? 3 different pairs. Okay. First of all, let us consider the angles which lies on same sides. Okay. Here, this one, angle 1. Angle 1 in the right side of this group. This represents first the angle 1, and here the first represent angle 5. So, such angles are called, having same position, okay, are called corresponding angles. So, there are 3 types of groups. Number 1, corresponding angles. Is corresponding pairs of angles. This is first pair. Which are corresponding pairs? Corresponding pairs means angles having same position. Same positioning from two different groups. This is first group, this is second group. Here this is first position. Here, so here it will be the first position. So angle 1 and angle 5. Angle 1 and angle 5. They form a pair of corresponding angles. Which are the two? Here, take 2 here. Consider 2. Angle 2. So, which of these represent corresponding to this 2? Here the second one is 2. Here which is second one? 6. Okay. Move anti-clockwise. Start from here 1, then 2. Start from here 5, then 6. So, 2 and 6. Angle 2 and angle 6. Second pair. Third pair. When you take 3, consider 3. Here, we have to go with 7. 3, 7. Angle 7. So, last one more pair is there. 4. Angle 4 is there. The angle corresponding to this 4 is 8. Angle 4, angle 8. Okay. And so, these are the corresponding pairs of angles. How many pairs of corresponding angles are there? 4 pairs. So, overall total 8 angles are there. All the 8 angles are considering to make corresponding pairs. Consider their positions. Okay. So, position here, the first position is here. Here, first position, this side. So, 1 and 5, 2 and 6, 3 and 7, 4 and 8. And also, these angles are equal. These angles are equal. So, angle 1 will be equal to angle 5. Angle 2 equal to angle 6. Angle 3 equal to angle 7. Angle 4 equal to angle 8. The measure of these corresponding pairs are always equal. Okay, so 1 and 5 are equal in measure, 2 and 6 equal, 3 and 7 equal, and 4 and 8 equal. So they are equal also. Equal Angle 1 equal to angle 5, angle 2 equal to angle 6, angle 3 equal to angle 7, and angle 4 equal to angle 8. So these are the properties of corresponding angles. So second, number 2. Considering interior angles. Interior angles. Now, first of all, we consider all the angles from 1 to 8. Now, for the second pair, we consider only interior angles. Interior means the angles which comes inside. Which of the angles comes inside? Come inside. Here 3, 4, 5, 6. These are the interior angle. And 1 and 2, 7 and 8 are exterior. Okay. They lies exterior of these lines, and these 3, 4, 5, 6 are interior angles. Okay. So there are two types of interior: alternate interior and co-interior. So first to go with alternate interior. So take one from here and one from here. Okay. Consider 3, which is alternate interior pair of 3 here. This is the alternate pair. Okay. It is same pair, same side. It is alternate side. So alternate side like X. Second pair is called alternate interior pairs of angles. There, first pair 3, angle 3 is alternate pair is 5, angle 5. Okay, a crossing. Angle 3 and angle 5. So one more is there, angle 4 and angle 6. They are alternate pairs. Angle 3 and angle 5, angle 4 and angle 6 represent alternate pairs. Okay. Also, they are equal. They are also equal. Angle 3 and angle 5, measures of angle 3 and angle 5 equal. Angle 4 and angle 6 also equal. How they become equal? We know that angle 3 equal to angle 1. Okay. Angle 3 equal to angle 1. Why? They are vertically opposite angles. Vertically opposite angles are always equal. So angle 3 will be equal to angle 1. Also we know that angle 1 equal to angle 5. Angle 1 and angle 5 are equal. Why? They are corresponding angles. Angle 1 is equal to angle 5. Angle 3 equal to angle 1. So from these two, we can conclude that angle 1 3 equal to angle 1 and angle 1 equal to angle 5. Then we can say that these two also equal. Angle 3 equal to angle 5 because both are equal to 1. So angle 3 equal to angle 5. Similarly, we get angle 4 equal to angle 6. So angle 4 will also be equal to angle 6 because angle 4 equal to angle 2. Angle 2 equal to angle 6 corresponding. Okay. Therefore, these 4 and 2 form vertically opposite, 2 and 6 form corresponding. So 4 and 6 are equal. So alternate interior pairs of angles are also equal. So how many pairs of alternate interior angles form? Only 2 pairs because they are interior angles. Only 4 interior angles are there. So 2 pairs are there. Okay. For corresponding pairs, there are 4 pairs because overall 8 angles are there. Next, last, number 3. Number 3. Interior angles also occur. First, in this case, we consider the alternate pair, that is opposite pairs. Okay, opposite angles. Now, consider the same side angles. 3, angle 3, the same side here, angle 6. Okay, this angle 3 come left, angle 6 left, so same side. Angle 4 right, angle 5 right. So 3 and 6 and 4 and 5. They are called co-interior angles. Co-interior pairs of angles. Co-interior angles also called the angles, interior angles on the same side of the transversal. Okay, you can call them either the interior angles on the same side of transversal or co-interior angles. Co-interior angles. Okay, co-interior angles or the angles on the same side of interior angles on the same side of transversal. Same side of transversal, left side and right side. So which are the pairs? Pairs are angle 3. Angle 3 pair with angle 6. Second, angle 4, angle 5. Angle 4 pair with angle 4. And how are they related? Whether they are equal or not. They are not equal because we know that 4 and 6 are equal, 3 and 5 are equal from here. Angle 3 equal to angle 5. We got angle 3 equal to angle 5 here. They are alternate pair. Angle 3 equal to angle 5. Also we know that angle 3 plus angle 4. What is angle 3 plus angle 4? Angle 3, angle 4, they form linear pair. Angle 3 plus angle 4 equal to 180 degree. Now substitute here 3. Implies 3 becomes 5. Because 3 equal to 5 plus angle 4 equal to 180 degree. Okay. Here angle 3 plus angle 4 equal to 180 degree. That becomes angle 5 plus angle 4 equal to 180 degree. Here we replace 3 by 5. That is 5 and 4. What type of angles are 5 and 4? 5 angle 5 and angle 4. Okay, angle 5, angle 4. They form co-interior angles and their sum is 180 degree. So their sum, when you add angle 4 plus angle 5, that is sum of co-interior angles, which will be equal to 180 degree. They are not equal, but they form supplementary angles. Okay, so we got this same. Similarly, we get angle 3 plus angle 6 equal to 180 degree. Okay. Now, these are the three different pairs of angles for when two parallel lines are intersected by a transversal. The first pair is corresponding pairs of angles, and the angles in each pair are equal. Second, alternate interior pairs of angles, and there are two pairs of angles, and angles in each pair are equal. In third case, co-interior angles or angles in the same side of transversal, and also two pairs are there, and the sum of the angles in each pair is supplementary. They are not equal, they are supplementary. They can be equal when the transversal is perpendicular to these parallel lines. Only when transversal is perpendicular to these parallel lines, then we can say that they are equal, because 90 plus 90, all angles becomes 90 degree, then 90 plus 90, 180, also 90 equal to 90. Co-interior angles form supplementary angles. Co-interior means supplementary. Alternate, equal, corresponding, equal. Okay, so just go through the alternate properties. Suppose it's a transversal and M parallel and 1 and let these two angles. What type of angles are there? Corresponding angle. Suppose when angle 1 equal to angle 2, that means corresponding angles are equal. When corresponding angles are equal, we can say that the lines are parallel. That is what is called a converse of corresponding angles axiom. Converse of corresponding angles axiom. So before coming to this question, I am going through that. What is converse? Converse of, first number 1, corresponding angles axiom. Axiom. Axiom means a statement which need no proof. Okay, so corresponding angles property is called corresponding angles axiom. We know that corresponding angles are equal when the lines are parallel. If two parallel lines are intersected by a transversal and making 4 pairs of corresponding angles, and the angles in each pair is equal. So here, suppose M and N are two lines, not given they are parallel lines, just they are two lines, and those lines are intersected by transversal T. Those lines are intersected by a transversal T, making angle 1 equal to angle. It is given that angle 1 and angle 2 are equal. Okay, not given that M parallel N. Only given M, N, N are two lines intersected by a transversal T. Okay, and angle 1 and angle 2 are equal. And what type of angles are angle 1 and angle 2? First of all, we have to find out what type of angles are 1 and 2. Angle 1 and angle 2. And we can say that angle 1 and angle 2 represent the same position from each group. So this is first group, first foregroup, second foregroup, and angle 1 and angle 2 are equal. This represents same position. That means they are called corresponding angles. Here corresponding angles are equal. Okay, it is given that two lines intersected by transversal and corresponding angles are equal. So what will happen when corresponding angles are equal? We know that to be equal, to be corresponding angles to be equal, the lines must be parallel. Then we can say that, which implies M parallel N. This is converse of corresponding angles axiom. When two lines are intersected by a transversal and if each pair of corresponding angles is equal, then the lines are parallel. Okay, that is corresponding converse of corresponding angles axiom. The original corresponding angles axiom is when two parallel lines are intersected by, in corresponding angles axiom, the lines are parallel. Here, the lines are not parallel. In that case, original case, in actual case, when two parallel lines are intersected by transversal, then corresponding angles are equal. Okay, here given is parallel lines and transversal, and after that we get equal corresponding angles. Next, in this case, in converse, given that corresponding angles are equal, then we can say that these lines are parallel. Okay, when lines are parallel, corresponding angles are equal. When corresponding angles are equal, then lines are parallel. Okay, so that is why this is called converse of corresponding angles axiom. So when corresponding angles are equal, we can say that the lines are parallel. Second case, converse of, again converse of alternate interior angles. Alternate interior angles theorem. Theorem and axiom, the difference between theorem and axiom. The axiom is a statement which need no proof, but theorem needs proof. We prove this alternate angles theorem with the help of corresponding angles theorem. Okay. Now what is converse of alternate interior angles theorem? Converse of alternate interior angles. That is, interior angles are equated. Here, given that, again given that M and N are two lines intersected by transversal T, and given that this angle, this is let it be A, let this angle be B. These two angles are equal, and here A and B are equal. What are A and B? A and B are interior angles. Which type of interior angles? Alternate interior angles. And given A equal to B. This is given. A equal to B. And what type of angles are A and B? A and B are alternate interior angles. Okay. So when alternate interior angles are equal, then we can say that the lines are parallel, which implies M parallel N. So that is converse of alternate interior angles axiom. So when two lines are intersected by transversal and each pair of alternate interior angles equal, then the lines are parallel. Okay, so only one pair is required. So here A equal to B, then M parallel N, and its opposite is when the original one is when M parallel N, then A equal to B. But the converse is when A equal to B, then M parallel N. Okay. Now third one. Just third one. Co-interior angles theorem. Converse of co-interior angle theorem. Okay, so consider converse of co-interior. Co-interior, which is co-interior of, this is the co-interior of A. Let it be B. So, co-interior angle property is A plus B should be 180. Given that A plus B equal to 180 degree. A plus B equal to 180 degree. And what are A and B? A and B form co-interior angles. A plus B equal to 180 degree. Then we can say that these lines M parallel N. Okay, so these are the three converse properties. So original properties, corresponding angles. When two parallel lines intersected by transversal, corresponding angles are equal. Original property alternate. When two parallel lines intersected by transversal, alternate interior angles are equal. Original property of co-interior. When two parallel lines are intersected by transversal, then each pair of co-interior angles is supplementary. That is 180. Next, it's converse. It's converse. If when two lines are intersected by transversal, making one pair of or each pair of corresponding angles equal, then we can say that the lines are parallel. So when two lines are intersected, two lines, not parallel lines, two lines are intersected by transversal, making each pair of alternate interior angles equal, then the lines are parallel. Again, when two lines are intersected by transversal, making each pair of co-interior angles supplementary, then the lines are parallel. Okay, so that is the difference. Either given parallel lines, then we can say that corresponding equal, alternate equal, co-interior supplementary. Or given corresponding equal, then lines are parallel. Alternate equal, then lines are parallel. Co-interior supplementary, then lines are parallel. Okay, so that is the difference between converse and the original property. So that's our question number 1. In figure 6.28, find the values of x and y and then show that AB parallel CD. To get two lines parallel, AB parallel CD, so we have to use the converse of either corresponding angles axiom or alternate angles theorem or co-interior angles theorem. So it is given two lines given, and these lines, name of these lines are AB and CD. This is AB, this is CD, and these lines are intersected by a transversal. Angles are given 50 degree here. Here it is x, this is y, and it is also given 130 degree. Okay, here you have to find out AB parallel CD. To find out AB parallel CD. So to be AB parallel CD, we have to get either corresponding angles equal or alternate angles equal or co-interior angles supplementary. Okay, so let's go through the answer. So here from this figure, you can find out the value of x and y. How to find value of x and y? Here x and y are alternate angles. Okay, when alternate angles are equal, then AB parallel CD. So first of all, find out the values of x and y using this value. We know that x and 50 degree. How are these angles related? What type of angles are they? These two angles are adjacent angles and they form linear pair. And we know that, so answer, we know that x plus 50 degree will be equal to 180 degree because they form linear pair. Okay, on line AB. Now, which implies x equal to 180 degree minus 30 degree, that is 130 degree. Okay, now we got the value of x, which is 130 degree. So first answer completed. Now come to this second line CD. On CD, what are these angles related? These are opposite angles. That means vertically opposite angle. When two lines intersect, two pairs of vertically opposite angles are formed. Angles in each pair are equal. Here y and 130. So y equal to 130 because they are vertically opposite angles. Vertically opposite angles are equal. Write all these answers. Okay. So we got the value of y 130 degree. Now compare x and y. So from above, which implies x equal to y equal to 130 degree. Okay. Now we have x and y are equal. X and y are equal. The what type of angles are x and y? And x and y are alternate interior angles. So what will happen when alternate interior angles are equal? So when alternate interior angles are equal, we can say that the lines are parallel. So that means here AB and CD are parallel. Okay. And x and y are alternate interior angles. Alternate interior angles, and therefore AB parallel CD. Reason by converse of alternate interior angles theorem. Okay, this is the reason. So answer completed. So it is very easy answer. Okay, now let's go to the second question. Question number 2. In figure, if AB parallel CD and CD parallel EF, given that AB parallel CD and CD parallel EF, and also Y is to Z equal to 3:7. Find X. Question, find X. So X is the figure. Okay. So three lines are given and a transversal. Okay. These are the angles given. Here we have to find out the value of x. Okay. So what is given here? Here given that these two lines are parallel. A, B, C, D. This is a symbol for parallel. Okay. These symbols represent these two lines are parallel. Also, AB parallel CD and CD parallel EF. Also, these two lines are parallel. CD, EF parallel. Then we can say that all these lines are parallel to each other. Okay. AB parallel CD. So first of all, we get AB parallel CD and CD parallel EF. Then we can say that AB parallel EF or AB parallel CD parallel EF. So start from the given AB parallel CD, CD parallel EF implies all of them are parallel. AB parallel CD parallel EF or AB parallel EF or AB parallel CD or CD parallel EF or all of them are parallel. Okay. So they are equal. So because lines parallel to same line are parallel to each other. Now what is the question? Find x. Y is to z is 3 is to 7. Y is to z is 3 is to 7. Okay. Y is to z is 3 is to 7. So let us consider this angle. There is no angle given. So let's go through that angle. Let it be another A, small a. Let this angle be A. Then now we have A equal to Y because they are vertically opposite angles. Then how are A plus Z related? A and Z related, they are co-interior. Then A plus Z equal to 180 degree. Okay. So it is given that Y is to Z equal to 3 is to 7. That is given. Okay. So when ratio given, let us consider Y equal to 3m. Okay. M is not there. 3m and Z is okay. Now which implies A equal to Y equal to 3m. Reason vertically opposite angles. The short form of vertically opposite angles. A equal to Y because they are vertically opposite angles. We know that vertically opposite angles are equal. So this is 3m. This is also 3m and Z is not 3m. Z is 7m. 7m. Okay. Z is 7. Now, how are these A and Z related? We know that A plus Z. Now go with A plus Z. A plus Z equal to 180 degree. Reason co-interior angles are supplementary. So which implies A plus Z. What is A? A equal to 3m. 3m plus Z is 7m equal to 180 degree. That is 10m equal to, which implies 10m equal to 180 degree implies m equal to 180 by 10 equal to 18 degree. Now we have m equal to 18 degree. M equal to 18 degree. Substitute here to get Y, A and Z. Okay. We have only to find out the value of S here. So we require either Y or Z. What type of angles are X and Z? Are these alternate? Are these lines AB? Here AB parallel EF and X, Z. Just avoid this CD. Suppose AB and EF are only AB and EF are there, then we can say that X and Z, they are alternate interior angles, and alternate interior angles are equal when the lines are parallel, because these two lines are parallel. Then X equal to Z. Then after getting Z, we will have X. So that's the easier way. Okay. Now find out Z. How to find out z? That is easier way. Or you can find the value of y, then x and y co-interior, then x plus y equal to 180. Other way step is there also there. We can find out z to find the value of x. Now z implies z equal to, what is z? 7m equal to 7 into 18 degree equal to 126 degree. Okay, so z is 126 degree. Now, since AB parallel EF, AB parallel EF, we can say that x equal to z, which is equal to 126 degree. Reason, alternate interior angles are equal. Okay, alternate interior angles are equal. So our second question over. Now come to the third question. In figure 630, if AB parallel CD, AB given AB parallel CD, EF perpendicular CD, perpendicular means intersected right angle, and angle GED equal to 126 degree. These are the given 126 degree. Find angle AGE, angle AGE, angle GEF, and FGE. Find these angles. Okay, figure given, two lines. This is a figure given. Here we know that this angle is 90 degree. So when this is 90, this will also be 90 degree. What is to find out? So angle GED, where is GED? Where is GED? This is GED. Angle GED, this is the angle GED is 126 degree given. Angle GED is 126 degree. Find AGE, GEF and FGE. So when this angle is 90 degree, it will also be 90 degree alternate interior angles. Okay, alternate interior angles are equal, so it will be 90 degree. This is AG. What will measure of this angle? AGE. Here AGE, what is GE is a transversal. So consider GE is a transversal. So suppose EF is not there, only GE. Okay, the only transversal is, let the only transversal be GE. So when GE is transversal, this is interior angle. Then what will be this angle related to this one? Alternate interior. So this angle and this angle, right? Correct? This one and this one, they are alternate interior angles, and we know that alternate interior angles are there. Then these two, this is given, this angle is 126, so it will also be 126 degree. And we know that first step, AB parallel CD, AB parallel CD, and on transversal GE, angle AGE will be equal to angle GED equal to 126 degree. Reason, alternate interior angles are equal. Okay, so first step over, first answer completed, 126 degree. Angle AGE completed, 126 degree. First angle GEF and FGE, next two. Angle GEF, this angle GEF, this is angle GEF. Angle GEF, the smaller one. Okay, the smaller one. Angle GEF. So how to find that angle GEF? This angle FED is 90 degree, and this total, this angle GED is 126. Then 126 minus 90 is GEF, angle GEF. See that from the figure, angle GEF. GED is formed by GEF and FED. So angle GED minus angle FED. GED, this is GED, GED, FED, this is FED. Okay, from this GED, take away this FED. Remaining is, this is the remaining part. Okay, this is the remaining part. That is the required part. So 126 degree minus 90 degree equal to 36 degree. Okay, so GEF completed. Now the last one, angle FGE. What is FGE? This is FGE. This angle. We know that what is sum of these two angles? This angle FGE and angle AGE. We know that angle AGE plus angle FGE equal to 180 degree. Therefore, these two angles form linear pair. Okay, so this is 126. So remaining will be 54 degree. So it will be 54 degree. So next step, last step, angle FGE. FGE plus angle AGE equal to 180 degree, linear pair. Which implies angle FGE plus AGE is 126 equal to 180 degree, which implies angle FGE equal to 180 minus 126. 180 degree minus 126 degree, which is equal to, what is 180 minus 126? 180 minus 126 is 54 degree. Okay, so completed. Everything complete. First one 126, second one 36, third one 54 degree. Now question number 3 completed. Okay, so let's start today's class.